Tonight, we are going to explore a feeling that doesn't really have a name. It's that distinct sensation you get when you stand on a beach at night, looking out at the black water, knowing it stretches on for thousands of miles. It is a mix of awe and dread. We think we know our place in the universe. We grew up seeing pictures of the solar system in textbooks. We see CGI renderings of galaxies in movies that we can zip across in seconds. But there is a lie hidden in those images. A comfortable lie that shields us from the true scale of reality. The truth is much stranger and much lonelier. You think you know what fast means. But what I'm about to show you reveals that the universe is not built for speed. It is built for silence. And once you understand this, you will never look at the night sky the same way again. Before we turn off the lights and step into the void, a quick click on the subscribe button helps us keep these journeys going. Now, take a breath. Let's begin. To understand how small we are, we first have to understand how fast we are not. Think about your commute. If you get in your car and drive on the highway, 60 miles an hour feels reasonable. It takes you an hour or two to visit a friend in the next town over. If you jump in a commercial airliner, you can cross an ocean in half a day. That feels fast to us. But let's scale up. Let's talk about the absolute speed limit of the universe. The speed of light, 186,000 miles per second. These are just numbers. They bounce off our brains. We didn't evolve to comprehend a number that big. So let's visualize it. Imagine a beam of light, a single photon. If we stay right here on the surface of the Earth, that beam of light is godlike. If I snap my fingers, that photon could circle the entire globe 7.5 times in 1 second, 7 times around the world, before you can even blink. Here on Earth, light is instantaneous. When you turn on a lamp, the room is illuminated instantly. When you play a video game, the signal feels instant. This creates an illusion. It makes us feel like we are connected to everything instantly. But Earth is a microscopic room. Let's pull the camera back just a little bit. Let's float out to our nearest neighbor, the moon. We see the moon every night. It feels close, like you could reach out and touch it. But if we send that same beam of light from Earth to the moon, suddenly the godlike speed starts to look human. Watch the beam leave Earth. It travels through the vacuum. And we wait 1 second, a little more, and almost 1.5 seconds later it hits the lunar dust. If you were on the moon and you tried to talk to your family on Earth, there would be an awkward 3-second silence between every sentence. An annoying lag, but bearable. But we are dreaming bigger than the moon, aren't we? We want to go to Mars. We want to be a multi-planetary species. So let's zoom out further. Let's look at the red planet. And this is where the horror sets in. This is where the speed of light is revealed for what it truly is. A crawl. Imagine you are standing on the red sands of Mars. You are lonely, you miss home. You send a message of love back to Earth. I'm okay, you say. That beam of light launches into the dark. It moves at 196,000 miles per second. The fastest thing in existence, and yet, watching it travel across the gap between the planets is like watching a snail cross a continent. From Mars at its closest approach to Earth, that beam of light takes 3 minutes to arrive. 3 minutes of silence, 3 minutes of nothingness. If you say, hello, you have to wait 6 minutes to hear hello back. And that is just next door. That is our backyard. If we zoom out to Pluto, that beam of light, traveling at maximum velocity, takes 5.5 hours. 5 hours just to say, I'm here. We are told that the speed of light is the fastest thing there is. But when you look at the true scale of the cosmos, the speed of light is agonizingly slow. It is a snail's pace. This is the speed limit of reality, and it traps us. We are living in a communication cage. Physics has built a wall around us. No matter how advanced our technology becomes, no matter how much energy we harness, we cannot shout faster than light can crawl. We are trapped in a bubble of time. And as we are about to see, when we leave our own solar system, this cage doesn't just make conversation difficult, it makes it impossible. Because if you think a 3-minute delay to Mars is lonely, wait until you see the gap between the stars. Let's bring this down to Earth. Because the human brain, for all its brilliance, is terrible at understanding big numbers. We hear 93 million miles to the sun, and we nod. We hear 4 billion miles to Pluto. And we nod again. To us, those are just numbers. Abstract concepts. They feel the same. So let's throw the numbers away. I want you to imagine we are standing in the middle of New York City, Times Square. I am holding a grapefruit in my hand. This grapefruit is the sun. It is the burning heart of our solar system, the source of all light and life, reduced to a piece of fruit you can hold in your palm. Now, if the sun is here, where is the Earth? You might think it's across the street, or maybe a few blocks down, but in this scale model, the Earth is a pinhead, a tiny blue pinhead floating about 15 meters away, roughly 45 feet, that's it. You are standing next to the grapefruit, and I am standing a few paces away holding a pinhead. That is our entire world. Between us, nothing, just air. Now let's take a walk. Let's walk past Mars, a grain of sand another 10 meters out. Let's keep walking until we find Jupiter. In our New York scale, Jupiter is a marble, maybe a cherry tomato, and it's sitting about a city block away. And this is where the picture in your textbooks lies to you. In school, you see the planets lined up, shoulder to shoulder, a colorful family portrait. But as we walk down this New York street, passing the marble that is Jupiter and the pea that is Saturn, you realize something unsettling. The solar system isn't crowded. It is mostly empty space. It is a few specks of dust floating in a massive, dark cathedral. And this brings us to the Traveler, Voyager 1. We launched this machine back in 1977. It is the fastest object humans have ever built. It is traveling at 17 kilometers per second. Think about that speed. A rifle bullet travels at maybe 1 kilometer per second. Voyager is moving 17 times faster than a gunshot. If you could travel that fast, you could fly from London to New York in under 5 minutes. Voyager has been screaming into the dark at that velocity for over 40 years. It passed the pinhead Earth. It shot past the marble Jupiter. It flew by the icy dust of Saturn. And then it just kept going for decades. And this is the part that is hard to stomach. Despite moving at 17 times the speed of a bullet for nearly half a century, in our grapefruit model in Times Square, Voyager 1 has barely left the neighborhood. It hasn't even left New York City yet. It is just now, after all this time, crossing into the suburbs. And what has it found out there? Nothing. Absolutely nothing. Since it passed Saturn in 1980, Voyager has been flying through a void so perfect, so absolute that it defies human comprehension. It isn't dodging asteroids. It isn't weaving between stars. It is moving through a silence so deep it would crush a human mind. We cheer for Voyager because it visited the planets. But the true story of Voyager isn't about what it saw. It is about what it didn't see. It is about the billions of miles of black static. And remember, we are still just in our own backyard. We haven't even talked about the other stars yet. Let's go back to our grapefruit in Times Square. If the sun is here, and the Earth is 15 meters away, where is the next star? Where is Proxima Centauri? Is it in Central Park? Is it in the Bronx? No. If the sun is a grapefruit in New York, the next nearest star is a grapefruit in San Francisco. Think about that. The Earth is a pinhead 15 meters away. The next star is 4,000 kilometers away, and in between New York and San Francisco, there are no other grapefruits. There are no melons. There are no marbles. There is nothing but empty, hollow space. An entire continent of emptiness. That is the true scale of our universe. We are not living in a dense forest of stars. We are living on a tiny grain of sand, drifting alone in the middle of the Pacific Ocean, and the nearest island is on the other side of the planet. And we are sitting here on our pinhead, wondering why no one has come to visit. So far, we have been comfortable. We have been playing in our own backyard. In the last chapter, we established that if the sun is a grapefruit sitting in the middle of Times Square, then Earth is nothing more than a pinhead hovering just 15 meters away, a tiny fragile speck of blue dust. Even Pluto, that lonely frozen outcast, is only a few blocks away in this model. You could walk there on your lunch break. It feels manageable. It feels intimate. Like a small town. But now, we have to leave the town. We have to leave the solar system entirely to find our nearest neighbor. We are looking for Proxima Centauri, the very next star. If you look at the night sky, or at scenes from Star Wars, you get this feeling that the galaxy is a crowded dance floor. You imagine that if you just hop in a spaceship and hit the thrusters, You'll be dodging stars like traffic cones. We assume the next star is just down the road, maybe in New Jersey, or if we're being generous, maybe as far as Washington, D.C. But this is where our human intuition fails us completely. This is where the scale breaks your brain. If our sun is a grapefruit in New York City, Proxima Centauri is not in New Jersey, it is not in Ohio, it is not in California. To find the next grapefruit, you have to leave the continent. You have to cross the Atlantic Ocean. In our model, the nearest star is another grapefruit located in Lisbon, Portugal. Think about that for a second. Picture the distance between New York and Portugal. Now, imagine walking that entire distance, step by step. What do you see along the way? Once you leave the coastline of North America, once you step off the continental shelf, what is there? For 3,500 miles, there is nothing. There are no other grapefruits. There are no melons. There are no marbles. There is nothing but empty, hollow space. An entire ocean of absolute nothingness. If you were a traveler making this journey in our model, you would spend years walking through the dark. Just you drifting over the deep water with absolutely nothing to mark your progress. No landmarks, no pit stops. Just the crushing weight of the void. And remember, this is just the nearest star. This is the house right next door. This is the true scale of our universe. We are not living in a dense forest of stars, where branches touch and leaves mingle. We are living on a tiny grain of sand, drifting alone in the middle of the Pacific Ocean, and the nearest island is on the other side of the planet. This vast, terrifying gap is what astronomers call the interstellar medium, and it is quieter than any silence you have ever known. It explains the isolation. It explains why, when we point our radio telescopes at the sky and listen for a signal, for a hum, for a whisper from anyone else, all we hear is static. Because the gaps are too wide. If there were a civilization living on that grapefruit in Portugal, and they looked back at New York with a telescope, they wouldn't see our pinhead Earth. They wouldn't see our cities or our wars or our Great Wall. They would see a faint, dying flicker of light in the darkness. So we sit here, on our pinhead, drifting in the dark, wondering why no one has come to visit. And perhaps the answer isn't that they don't exist. Perhaps the answer is simply that the ocean is too big. But that ocean, that emptiness between the pinheads, is just the space between neighbors. We have only just left our front porch. Now we need to look at the city we live in, the Milky Way. It is easy to look at a picture of a galaxy and think of it as a cloud, a solid, glowing disk of white light. It looks dense, it looks crowded, but appearances are deceiving. To truly understand the scale of our galaxy, we have to break the laws of our own biology. We have to get microscopic. I want you to imagine a single drop of blood. Inside that drop are millions of red blood cells. Pick one. Just one microscopic cell invisible to the naked eye, floating through a vein. Now, imagine that single, tiny cell is our sun, the massive burning engine that dwarfs our Earth, reduced to a microscopic speck. If our sun is that blood cell, then the Milky Way galaxy is not a room, it isn't a stadium, it isn't even a city. If our sun is a single blood cell, the Milky Way is the size of the continental United States. Picture that. A single blood cell placed in San Francisco and another one in Washington, D.C., and filling the space between the coasts. 100 billion other microscopic cells, drifting, floating, lost in a body the size of a continent. That is the density of our galaxy. We are not a cloud, we are a collection of lonely specks, separated by miles of absolute nothingness, pretending to be a solid object because we are viewing it from too far away. And just like blood circulates, we are moving. We tend to think of the solar system as stationary. We sit in our chairs, the Earth spins, the Earth orbits the sun, and we think the sun just sits there, fixed in space. It doesn't. We are on a carousel. Our sun and all of us dragging along behind it are orbiting the supermassive black hole at the center of the galaxy at a speed of 500,000 miles per hour. That is fast enough to travel from New York to London in 20 seconds. We are screaming through the void. But the track is so insanely long. The United States of our galaxy is so vast that we barely make a dent in the journey. This brings us to the most humbling clock in existence, the galactic year. It takes our solar system 230 million Earth years to complete just one single lap around the Milky Way. One orbit, one galactic birthday. Think about where we are right now. In this specific patch of the cosmic void, look at the stars above you tonight. The last time our solar system was in this exact position, the last time we were here, humanity did not exist. We weren't even a thought. There were no cavemen, no apes, no mammals as we know them. The last time we were here, the dinosaurs were just beginning to rise. The supercontinent Pangaea was just starting to crack apart. Entire species have risen, dominated the planet for millions of years and gone extinct, turned to dust and fossils, all while we were just rounding the bend of a single orbit. Since the Sun was born 4.5 billion years ago, we have only made this trip 20 times. 20 laps, that is the entire history of our solar system. We are not residents of space, we are tourists, traveling through a galaxy that is mostly empty space, on a timeline that makes the history of our species look like a single frame in a 3-hour movie. We drift from one side of the continent to the other, microscopic blood cells in a body we will never fully explore, illuminated by a sun that is just one of billions, islands of light, separated by oceans of time. And yet, if you think this is big, if you think the United States made of stars is the limit of our reality, you are about to find out that our galaxy, our massive, spiraling home, is just a speck of dust on a much, much larger lens. So we've left the Milky Way. Take a last look at it. That spiraling city of stars, holding every human being who has ever lived, every story ever told, every king and every peasant, is now receding behind us. It shrinks from a continent, from an island, to a coin, from a coin to a single, lonely pixel of light, and then it vanishes into the crowd. Because where we are now, the scale of reality shifts so violently that the human mind simply refuses to process it. We have entered the realm of the superclusters. Imagine you are in a dark room and you turn on a flashlight. Dust motes dance in the beam. Thousands of them, floating, drifting. In this picture, our entire galaxy, our home with its 200 billion suns, is just one of those pieces of dust. And we are not floating aimlessly. We are being pulled. If you map the motion of the galaxies around us, something strange begins to happen to the image. The stars disappear. The darkness disappears. What you are left with looks frighteningly familiar, looks like veins. It looks like the root system of a forest. It looks alive. This is the cosmic web, the skeleton of the universe. Filaments of dark matter and gas, stretching across hundreds of millions of light years, connecting galaxies like nodes in a supercomputer. And right here in this specific cluster of veins is our true address. Scientists call it Laniakea. It's Hawaiian for immeasurable heaven, and the name fits. Laniakea contains 100,000 galaxies, 100,000 versions of the Milky Way, all flowing together like rivers down a mountain. But rivers flow towards something. And this is where the vertigo sets in, because we are moving. You, me, the Earth, the Sun, the entire Milky Way. We are moving at 1.3 million miles per hour towards a specific point in the dark. We are being dragged towards a gravitational anomaly so massive, so dense, that it is bending the fabric of the universe around it like a heavy stone on a trampoline. They call it the Great Attractor. We can't see it. It lies hidden behind a wall of dust and gas in our own galaxy, in a region astronomers call the zone of avoidance, a blind spot in our vision. We only know it's there because we can feel it pulling, a gravitational scream in the silence. It pulls us. It pulls Andromeda. It pulls thousands of other galaxies into its embrace. When you look at the simulation of the universe at this scale, when you see the fibers of light connecting the void, it doesn't look like physics anymore. It looks like biology. It looks like a neural network, like the firing neurons inside a human brain. Think about that for a moment. Really let that sink in. The structure of the largest thing we know mimics the structure of the thing we use to understand it. As above, so below. If the universe looks like a brain, if the galaxies are just firing synapses, then what are we? Are we the bacteria crawling on a single atom of a single neuron? Or are we just a fleeting thought? We look at this colossal web, stretching out for billions of light years, and we realize that the spaces between the galaxies, those black voids, are millions of times larger than the galaxies themselves. It is mostly empty. It is cold. and it is terrifyingly organized. We are not just residents of a solar system. We are not just citizens of a galaxy. We are a microscopic part of a flowing, breathing, living structure that dwarfs the very concept of size. And yet, we haven't even reached the edge. Because even Laniakea, even this immeasurable heaven of 100,000 galaxies, is just a small ripple in a much larger pond. If we zoom out one last time, the structure changes again, and what we see next might just break you. So let's take that final step back. We leave Laniakea. We leave the superclusters. We leave the filaments of the cosmic web behind. We are now floating in the void, looking at the sum total of everything we can possibly see. And this is where the human brain usually shuts down, because we aren't just looking at distance anymore. We are looking at time. You see, light is fast. It is the fastest thing there is. It can circle our little Earth 7.5 times in a single second. To us, that feels instant. If you turn on a lamp in your living room, the room fills with light immediately, but the universe is not a living room. On the scale we are looking at now, light is agonizingly slow. It is a snail crawling across a continent. Think about it like receiving a letter in the mail. If a friend sends you a letter from the next town over, what you are reading is news from yesterday. If that letter comes from the other side of the world, maybe it's news from a week ago. The deeper into space we look, the further back in time we travel. When we looked at the moon, we saw it as it was 1 second ago. When we looked at the neighboring stars, we saw them as they were 4 years ago. And when we looked at Laniakea, we were watching ghosts. We were watching a history that happened hundreds of millions of years before humans even walked the earth. But there is a limit. There is a wall. If you take the most powerful telescope we have, and you point it at the darkest patch of sky, and you keep the shutter open for days, weeks, months, eventually you hit a barrier. It isn't a black wall, it is a wall of fire. It surrounds us on all sides, a sphere of ancient, fading radiation. We call it the cosmic microwave background. This is the edge, not the edge of space. Space likely goes on forever, but the edge of time. This is the baby picture of our universe. This light has been traveling toward us for 13.8 billion years. Before this moment, the universe was so hot, so dense, that light couldn't travel at all. It was a fog of plasma. So when we look at this wall, we are looking at the moment the fog cleared. We are looking at the first breath of the cosmos. Everything we know, every star, every planet, every galaxy, every person who has ever lived or died, is trapped inside this sphere. We call it the observable universe. It is a bubble of reality 93 billion light years across. And here is the part that keeps astrophysicists awake at night. Here is the part that creates a profound sinking feeling in your chest. We are trapped in the bubble, and the bubble is shrinking. Well, not literally shrinking, but our access to it is disappearing. You see, space is not static. The space between the galaxies is stretching. It is expanding. Imagine drawing dots on a balloon and then inflating it. The dots move away from each other, not because they are walking, but because the rubber itself is growing. Right now, distant galaxies are being carried away from us by this expansion, and the further away they are, the faster they go. There is a terrifying threshold out there, a point of no return, a cosmic horizon. Beyond a certain distance, the space between us and a galaxy is expanding faster than the speed of light. Think about that, faster than light. That means the light leaving those galaxies today will never reach us. They are sending us messages, images of their stars, their potential civilizations, their futures. But the space is stretching faster than the message can travel. It is like trying to run up a down escalator that is moving too fast. You will never reach the top. Those galaxies are slipping over the horizon. They are falling off the edge of our reality forever. Every second that passes, every word I speak right now, another region of the universe disappears from our reach. Thousands of stars, entire worlds, are crossing that line, fading into the dark, severed from our destiny. If we could build a spaceship that travels at 99.9% the speed of light, and we left today, we could never catch them. They are already gone. We are living in a rare, golden era of cosmology. We are lucky enough to exist at a time where we can still see the neighbors. Billions of years from now, the expansion will be so vast that the other galaxies will have rushed away out of sight. future civilizations born in our galaxy. They will look up, and they will see nothing but their own stars. They will think the Milky Way is the entire universe. They will see an empty, static void surrounding them. They will have no way of knowing about Laniakea, no way of knowing about the Big Bang, no way of knowing about the expansion. History itself will be erased by the distance. So, how small are we? We are incredibly small in space, yes, but we are even smaller in time. We are a brief flash of consciousness, standing on a drifting rock, watching the rest of the universe slowly, quietly walk away from us. But take a breath. Don't let the darkness win just yet, because the fact that we know this, the fact that a microscopic collection of atoms, you and I, can stand on this rock, look up at the ancient light, and calculate the size of our own prison. That is the miracle. We have mapped the bubble. We have stared at the wall of time. And for a brief, shining moment, we understood it. So, where do we go from here? If we are trapped in this bubble, what is left? Well, we might not be able to leave the universe. But maybe, just maybe, we aren't the only ones looking back. Let's talk about life. We call it the observable universe. That word is doing a lot of heavy lifting. Observable, it sounds technical, safe. But it is actually a confession. It is an admission of blindness. Imagine you are on a ship in the middle of the Pacific Ocean. It is the middle of the night. Pitch black. No moon. You are standing on the deck, holding a small lantern. The light from that lantern stretches out, maybe 20 feet in every direction. It illuminates the railing. A bit of the dark water may be the spray of a wave. That circle of light is the observable universe. That is the 93 billion light years we just talked about. That is the bubble, containing every galaxy, every star, and every history book we have ever written. But here is the question that keeps cosmologists awake at night. Does the ocean end where the light stops? Of course not. The ocean goes on dark, cold, unseen, and if the theory of cosmic inflation is correct, the ocean doesn't just go on for a long way, it goes on forever. This is where the scale of reality shifts from being merely large to being mathematically terrifying. We believe that in the first fraction of a second after the Big Bang, space didn't just expand, it inflated. Like a loaf of bread rising in the oven, but faster than the speed of light. The theory suggests that this expansion was so violent and so fast that the part of the universe we can see, our lantern light, is just a microscopic patch on an infinitely large surface. We are living on a bubble, on an infinite loaf of bread. Now you might say, okay, so the universe is infinite. That just means there's more empty space, more rocks, more dead stars. Who cares? You should care, because infinity does something very strange to probability. It breaks it. Let's play a game. Think of a deck of cards. 52 cards. If you shuffle that deck, the chances of getting a specific order are incredibly low. But if you shuffle that deck enough times, eventually the order will repeat. It has to. There is a limited number of ways you can arrange 52 cards. It is a huge number, but it is finite. If you shuffle forever, repetition is a mathematical certainty. Well, you are a deck of cards. Not cards, obviously, but particles. You are a collection of atoms arranged in a very specific way to create your brain, your memories, your hands, and the screen you are looking at right now. The number of ways to arrange atoms in a space the size of a human being is mind-bogglingly massive. It is a number so big we don't even have a name for it. But it is finite. There is a limit to how many ways you can build a human. So if the universe is truly infinite, if the ocean goes on forever, then nature is forced to shuffle the deck an infinite number of times. Do you see where this is going? If you travel far enough, past the edge of the observable universe, past the wall of ancient light, across the great dark ocean of the multiverse, eventually you will run out of new arrangements. Eventually, the particles have to repeat. Calculations suggest that if you travel about 10 to the power of 28 meters, you will find a bubble of space exactly like this one, with a galaxy exactly like the Milky Way, a sun exactly like ours, a planet exactly like Earth, and on that planet, there is a room exactly like the one you are sitting in, and in that room is you, not a clone, not a twin, you, an exact copy, with the same scars, the same first memory, the same name, looking at the same screen, hearing these same words at this exact same moment. Maybe, in that universe, you decided to wear a red shirt today instead of a blue one. Maybe in another, you didn't click on this video. Maybe in another, you are the one speaking. In an infinite universe, anything that can happen happens, and it doesn't just happen once. It happens an infinite number of times. It is a thought that makes you feel incredibly small, doesn't it? We want to be special. We want to believe that this version of us, this life, this consciousness, is unique, a one-time event in the cosmos. But the math suggests we are just a repeating motif in an endless wallpaper. It sounds like a nightmare, to be just one copy among infinite copies. But I choose to look at it differently. We spent the last chapter feeling trapped. We felt locked inside our bubble of light, isolated from the rest of existence by the speed of light itself. We felt lonely, a single fragile species on a rock, shouting into the void with no one to hear us. But if this is true, if the ocean is truly infinite, then we are not isolated, and we are certainly not rare. We are everywhere. We are the song the universe cannot stop singing. We might be trapped in our bubble, unable to ever meet those other versions of ourselves. We can never cross that horizon. But there is a strange comfort in knowing that out there, in the unseen ocean, the lights are on, and someone with your eyes is looking back into the dark, wondering if they are alone. So, we have mapped the bubble. We have theorized the ocean. We have realized that life is not an accident but an inevitability. But that brings us to the final problem, the hardest one. If the universe is infinite, and we are repeating forever, does anything we do here actually matter? Let's talk about meaning. Let's talk about meaning. Because if we stop here, with just the maps and the math, we are left with a very heavy feeling in our chests. I know you feel it. I feel it too. It is the vertigo of the scale. We have spent this entire journey zooming out. We went from your front door, to the atmosphere, to the moon, to the edge of the solar system. And then we kept going until the sun was just another grain of sand in a beach that never ends. When you look at the universe through a telescope, the first emotion is awe, but the second emotion is usually terror. Because if the universe is that big, then you are effectively zero. You are a microscopic biological accident, clinging to a wet rock, circling a mediocre star, in the forgotten suburbs of a galaxy that is crashing into nothingness. If you vanish tomorrow, the universe will not blink. The stars will keep burning. The galaxies will keep spinning. Entropy will keep marching toward the heat death. It feels like a sick joke. To be given the consciousness to understand the infinite, only to realize that the infinite does not care about you. But I want you to try something different. I want you to stop measuring significance with a ruler. We have this bad habit as humans. We assume that big equals important. A mountain is more important than a pebble. A skyscraper is more important than a brick. A star is more important than a human. But let's look at that star again. Pick one. Betelgeuse. It is a red supergiant. If you dropped it where the sun is, it would swallow Mars. It is colossal. It is violent. It is majestic. But it is also stupid. It's just gas. It's just physics obeying gravity. It doesn't know it's a star. It doesn't know it's red. It doesn't feel the heat. It has no plans, no fears, no loves, and no questions. It is 1,000,000,000 times bigger than you, yes. But it is dead inside. Now look at yourself. Look at your hand. Inside that hand, there is a complexity that makes a star look like a child's drawing. You are not just a collection of atoms. You are a collection of atoms that has organized itself so specifically, so intricately that it has woken up. Think about the odds of that. For billions of years, the universe was just rocks crashing into rocks, fire and ice, static and silence. And then, seemingly out of nowhere, the atoms started telling stories. This is the twist. This is what changes everything. We are not separate from the universe. We are not visitors here. We vara the universe. We are the part of the universe that learned how to open its eyes. When you look up at the night sky, you are not a tiny observer looking at a massive object. You are the universe looking at itself. You are the mechanism by which the cosmos understands its own grandeur. Without you, without life, without consciousness, the universe is just a play performed to an empty theater. It might as well not exist at all. Size is irrelevant. Scale is a distraction. Significance is found in the ability to comprehend. And this brings us to the concept of optimistic nihilism. If the universe has no inherent meaning, if there is no great script written in the stars, then we are free. If nobody is watching, you don't have to perform. If the universe doesn't care, then the only things that matter are the things you decide matter. The coffee you had this morning, the way the light hits the floor in the afternoon, the sound of your friend's laugh. These things are not small. They are the only things that are real. We spent this whole time terrified of how small we are compared to the void. But we forgot to check if the void can feel love. It can't. You can. That makes you the most important thing in it. So let's go back to that pale blue dot. Yes, it is a speck of dust suspended in a sunbeam. Yes, it is fragile. But it is also the only place in the entire known existence where there is music, where there is poetry, where there is forgiveness. We are small. Physically, we are nothing. But in terms of complexity of consciousness, of capacity for feeling, we are giants. So tonight, when you turn off the screen and look out the window, don't be afraid of the dark. Don't be afraid of the silence. Just remember, you are the universe. And for a brief, flickering moment, you get to decide what it all means. The lights are on, and you are home.